Welcome once again into my YouTube channel whose name is Knowledge Entertainment, and we continue from where we have left the topic in yesterday's video. So now the term is for properties of trigonometric functions. So we have learned that what are the trigonometric functions: sine theta, cos theta, tan theta, secant, cosecant and cot theta. There are some basic identities which you must have learned in your 9th or 10th class, that is cos square x plus sine square x is equal to 1. The second one is 1 plus tan square x is equal to secant square x, and the third one is 1 plus cot square x is equal to cosecant square x. So these are the three basic identities which we will use in making further properties. One more thing which I want to discuss, that in coordinate geometry, if there are 2 points, one is with coordinates x1 and y1, and there is another point with coordinates x2 and y2. Suppose this is the point A, this is the point B. Then the distance between these 2 points, that is mod AB, is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. Means square of the difference of first coordinate and square of the difference of the second coordinate, their sum, and then square root is the distance between the 2 points, which we will use today in making trigonometric identities. So let us start with the value of these trigonometric functions in different coordinates. So here, this is your x-axis, y-axis, this is your first quadrant, here is your second quadrant, third quadrant and fourth quadrant. First quadrant covers angles from 0 degree to 90 degree, that means 0 to pi by 2. Second quadrant covers the angles from pi by 2 to pi, that means 90 degree to 180 degree. And then third quadrant from 180 degree to 270 degree. And fourth quadrant from 270 degree to 360 degree, that means 3 pi by 2 to 2 pi. There is one rule, that is A, S, T and C. Here A means all, that means all the trigonometric functions consume positive values in the first quadrant. If you want to know the value of cos 56 degree or sine 82 degree or tan 68 degree, cot 41 degree, secant 28 degree, cosecant 18 degree, any value of any trigonometric functions lying between 0 and 90, whatever the value will be, it will be positive because all are positive here. In the second quadrant, that means from 90 degree to 180 degree, only 2 functions, one is namely sine and another one is its reciprocal, that means cosecant. These 2 are positive and rest of the trigonometric functions are negative. If you want to know the value of cos of 120 degree, then 120 degree is in the second quadrant and cos is negative, so value of cos of 120 degree will be negative. Similarly, in the third quadrant, that means if you have some trigonometric function with angle lying between 180 degree and 270 degree, then T means tan and its reciprocal cot. Only these 2 trigonometric functions will have positive values and rest of the trigonometric functions will have negative values. In the fourth quadrant, that means between 270 degree to 360 degree, the trigonometric functions only 2. Which 2 are these? These are C. C means cos and its reciprocal secant. These 2 will be positive and rest of the trigonometric functions will assume negative values. Now, how to learn this ASTC. So there are so many methods. Some people learn it like all students ticket collector. So this is one method. You can keep it in mind. That is ASTC. Some people say all silver tea cups, and all silver tea cups again is ASTC. So keep it in mind. Or you can say another thing is that after school to college. After school to college is again ASTC. So it is another method to keep it in mind. And if you want to take it some light, then you can say after school to cinema. So it is again ASTC, after school to cinema, after school to college, all silver teacups, all students ticket collector. So this is the method how to keep it in mind which of the trigonometric functions are positive in which quadrants and which of the trigonometric functions are negative therefore. So this is the trick, this is the method. And now one more thing. If you are having a trigonometric function of the type this, I will have to rub now because I want to proceed now to the angles further, but this table will also be required. So I will have a short image now here, a short image here, first quadrant, second, third, fourth with ASTC. This is your 0 degree, 90 degree, 180 degree, 270 degree, and this is once again 360 degree. Now, if you want to find some values, suppose I am writing some of the trigonometric functions like sine 90 minus theta, cos 90 minus theta, cosecant 90 minus theta, tan 90 plus theta, secant 90 plus theta, cos 180 minus theta, cot 180 plus theta. Then I am writing tan 180 plus theta, sine 270 minus theta, cos 270 plus theta, tan 360 minus theta, secant 360 plus theta. So how to find these values is the question now. So two things you are to keep in mind. The first one, you are having it here, that in the first quadrant all the trigonometric functions are positive. In the second, sine and its reciprocal cosecant are positive, rest of the trigonometric functions are negative. In the third quadrant, tan and its reciprocal cot are positive, rest of the trigonometric functions are negative. In the fourth quadrant, cos and its reciprocal secant are positive and rest of the trigonometric functions are negative. Secondly, you have to keep it in mind when there is 90 or 270 and when there is 180 and 360. These are two different cases. These are two different cases. When there is 180 or 360, trigonometric function not going to change. Not going to change. If it was sine, then it will remain sine. If it is tan, it will remain tan. If it is cosecant, it will remain cosecant. But if it is the case of 90 or 270, what will happen? Sine will change to cos and vice versa. Tan will change to cot and vice versa. Secant will change to cosecant and vice versa. If you understand these two things, then these conversions are very easy. So let us start. So first one is there is 90. So in case of 90, we know that sine is going to change to cos. So this sine 90 minus theta will become cos theta. Now what about the sign, positive or negative? This sine 90 minus theta, so you are starting from here 90 and then back minus theta, you will be in the first quadrant. And in first quadrant, since all the trigonometric functions are positive, so why not sine? You have to look at this function, not this. So sine will also be positive, so your answer will be cos theta. For the second case, it is once again 90 minus theta. So 90 minus theta, you are in the first quadrant, and since it is 90, so because of 90, sine is going to change into the cos, and cos is going to change into the sine. So this cos will change into sine theta, and since sine, so this 90 minus theta in the first quadrant, so cos will also be positive, it will not be negative. Then cosecant 90 minus theta. Once again it is 90. Since 90, this cosecant will convert into secant. So this will become your secant theta. And what about the sine, plus or minus? 90 minus theta is in the first quadrant, and in the first quadrant all the trigonometric functions are positive. So cosecant will also be positive. So you will get here a positive sign, that means simply secant theta. Now move on to the next. Here it is 90 plus theta. First of all, it is the case of 90. So in case of 90, your tan is going into change into cot. So this tan will be converted into cot theta. It will be converted into cot theta, and 90 plus theta now. So it is your 90 and plus theta will take you into the second quadrant. So into the second quadrant, you know that sine is positive, its reciprocal cosecant is positive, rest of the trigonometric functions are negative, and your trigonometric function is tan. So tan is negative. So because it is negative, you will get a negative sign here. Then secant 90 plus theta. Once again it is a case of 90. So in case of 90, your secant is going to change into cosecant. So it will become cosecant theta first of all. And now sine, plus or minus. So it is 90 plus theta. So 90 plus theta is in the second quadrant, and in the second quadrant sine and cosecant are positive, rest are negative. So secant will also be negative. So you will get a negative sign here. Move on to the next. It is 180. And 180 and 370. Trigonometric function is not going to change. If it is cos, it will remain cos. So you will get cos theta. Now, what about plus or minus sign? It is 180 minus theta. So this is your angle 180, and minus theta will take you back into the second quadrant. In the second quadrant, sine and cosecant are the only positive trigonometric functions. It is neither sine nor cosecant. It is cos. So it will have a negative sign here. So cos 180 minus theta will become minus cos theta. Once again, it is 180. And 180 means trigonometric function is not going to change. This cot will remain cot. So it will be cot theta. And what about the sign plus or minus? It is 180 plus theta. This is your 180, and plus theta will take you into the third quadrant. In third quadrant, tan and its reciprocal cot are positive, and your function is also cot. So tan and cot are positive, so this will also be positive. So you will not put a negative sign here. Cot of 180 plus theta will become cot theta. Similarly, it is tan 80 plus theta, 180 plus theta. 180, trigonometric function is not going to change, so it will remain tan theta. It will remain tan theta, and 180 plus theta. This is 180 plus theta will take you into the third quadrant. In third quadrant, your tan is positive, so no need to put a negative sign here. It will remain as it is. So tan 180 plus theta is tan theta. Then sine 270 minus theta. Once again 270. And in case of 270, your sine is going to change into the cos. So it will become cos theta. It will become cos theta, and 270 minus theta. This is your 270, and minus theta will take you back into the third quadrant. In third quadrant, tan and cot are positive, so your sign will be negative, so we'll have to put here a negative sign. Then next is 270 plus theta. Once again it is 270, so your cos is going to change into the sign, so you will get here sin theta. And what about positive or negative sign? So 270 plus theta, it is your 270, and plus theta will take you into the fourth quadrant. In fourth quadrant, your cos and secant are positive, and here the function is cos. Cos is positive, so no need to put here a negative sign, it will remain as it is. So cos of 270 plus theta will become equal to sin theta. Now tan 360 minus theta, case of 360. 360, no change, so tan will remain tan. So you will get here tan theta. And now we'll talk about the sign, plus or minus. 360 minus theta. So it is your 360 minus theta will take you back into the fourth quadrant, and in fourth quadrant only cos and its reciprocal secant are positive, and your function is tan, so you will have to put here a negative sign. So tan 360 minus theta is minus theta, minus tan theta. Secant 360 plus theta. Once again the case of 360 trigonometric function is not going to change, so secant will remain secant theta. And what about negative or positive sign? So it is 360 plus theta, it is your 360, and plus theta will take you into the first quadrant. In first quadrant all the trigonometric functions are positive, so secant will also be positive, so the result will be secant 360 plus theta is equal to secant theta. This is the way how to calculate the values of the allied angles. These are not the basic angles, because basic angles are from 0 to 90 degree, and to be more fundamental, these are the angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Rest of the angles which are greater than 90 degree, they are allied angles, and how to calculate allied angles is this method. We will take some examples as well. So let us take some examples. This is actually the basic formulation. And now suppose you have to find the value of tan 225 degree. So tan 225 degree, you can write tan 180 plus 45 degree. Now this 45 degree is your theta, so it is tan 180 plus theta. Now it is a case of 180. In case of 180, your trigonometric function is not going to change, so it will become equal to tan 45, but still we have to check whether it is positive or negative. It is 180 plus 45. It is your 180, and plus 45 will take you into the third quadrant, and in third quadrant your tan is positive, and here again your function is tan, so it will remain positive, and there will be no negative sign, and value of tan 45 from the previous lecture you know that it is 1. So value of tan 225 degree is equal to 1. Let us take one more. Let us find the value of cos of 150 degree. Cos of 150 degree, you can write cos 90 degree plus 60 degree. So this 60 degree will be your theta now. So it is cos 90 plus theta. 90 plus theta, it is your 90, and plus theta will take you into the second quadrant. In second quadrant, your cos will be negative. So first put out a negative sign here. And it is cos 90 plus theta. Case of 90 degree, your cos is going to change into sine. So this cos 90 plus 60 will become sine 60 degree. Sine 60 degree. And from the previous lecture, you know that the value of sine 60 degree is root 3 by 2. So it is minus root 3 by 2. So this is how you can calculate the values of the trigonometric functions of allied angles. So now we will move ahead to more formula, and basically I will try to give you a proper proof. First I am going to prove there is the formula that cos of x plus y is equal to cos x cos y minus sin x sin y. So we will look into the proof of this trigonometric identity. First of all, draw a unit circle. This is unit circle, and the center of the circle I am taking it at the origin. Origin is the center of this unit circle. We know that one thing, if there is a point here and I am joining origin to this point, I am joining this. Suppose this angle is theta, then coordinates of this point will be cos theta, sin theta. Why? The answer is very easy. Draw a perpendicular line from here. This is your O, this is your M, this is your N. And radius is 1 because it is unit circle. Now what is OM? You just take OM upon ON. OM upon ON. Since we are taking about this angle, this will be your perpendicular, this is hypotenuse, and this is your base. OM is the base. So base upon hypotenuse. Base upon hypotenuse is cos theta. So it is equal to cos theta. And the value of ON is 1. So you put the value of ON here equal to 1. And using cross multiplication you will get OM is equal to cos theta. So this length is going to be equal to cos theta. This is. Similarly, MN upon ON is equal to, this MN is your perpendicular and ON is hypotenuse. Perpendicular over hypotenuse is sin theta. So it will be sin theta. Once again, the value of ON is 1, and by cross multiplying you will get MN is equal to sin theta. So this is your sin theta. This is your sin theta. So this is origin. What will be the coordinates of this point? This is cos theta, x coordinate, and sin theta, y coordinate. So the coordinates will become cos theta and sin theta. So similarly, on any point of the circumference of this circle, if you take some point, if the line joining that point to the origin, if it subtends an angle of theta, then the coordinates of that particular point will be cos theta and sin theta. So this is the basic thing. And now I am going to the proof. I am moving to the proof of this identity. That means cos of x plus y is equal to cos x cos y minus sin x sin y. So let there be a point A. Let there be a point A. If I'll talk of the coordinates of the point A, what will be the coordinates of the point A? It is very easy. The point is lying on the x-axis. This is your x-axis. This is your y-axis. If a point is lying on the x-axis, then its y-coordinate is automatically 0. And what is the x-coordinate? Is the distance of the point from the origin. And distance of the point from the origin is OA. But OA is also radius of the circle, and radius of the circle is 1. So your x-coordinate is 1 and y-coordinate is 0. So the coordinates of the point A are 1 and 0. These are the coordinates of the point A. Suppose there is a point B and OB subtends an angle of x with a positive direction of x-axis. Then the coordinates of B will be cos x, sin x, as we have discussed just now. Then travel y-axis more. Y angle more. Travel y angle more, and you will get this point on the circumference. Suppose this is the point C. Now this is the angle x, this is the angle y. What is the angle that OC subtends on the positive direction of x-axis? That means this complete angle. I am talking of this angle now, and this angle is x plus y. If OC subtends an angle of x plus y with the positive direction of x-axis, then the coordinates of the point C will be cos x plus y, sin x plus y. These will be the coordinates of the point C. This is your angle y. Now subtend minus y here, minus y, because I am taking it clockwise, not anti-clockwise now, so it will be minus y, and you will get another point. Suppose this is the point, and the coordinates of this point will be cos minus y, sin minus y, by the same rule. Now look at what we are going to have. Now look at what we are going to have. I am considering two triangles. So what the two triangles are? One triangle I am taking this. This is O, A, and you can say this is the point C. And this is the point I am taking D. O, A, C. Also consider the triangle this OB, OC, and join BD. So I am considering two triangles. Triangle AOC and triangle BOD. If you look at carefully, then these two triangles are congruent to each other. Why they are congruent? Because two of the sides of each of these triangles is equal to the radius of the circle. That means OA is same as OB and OC is same as OD. Two of the sides are same. Thirdly, what is the angle AOD? This angle is Y. Angle BOD, this angle ABOD is also Y. So you are having Y angle in both the cases. So one is the triangle OAC and another is the triangle BOD. They are congruent triangle, and when two triangles are congruent, then their corresponding sides are also equal. And I am taking the corresponding sides at AC and BD. So AC is equal to BD. When AC is equal to BD, their squares must also be same. AC square is equal to BD square. Now look at what is BD square. BD square. BD is the distance between 2 points, one with coordinates cos x, sin x, other with coordinates sin minus y and cos minus y. So distance between these 2 points and square of that, because of the square root on the other side will be removed, and the distance will become cos x minus cos minus y square plus sin x minus sin minus y square. So what you will get? You will get one more thing to keep it in mind, that cos of minus y is cos y and sin of minus y is equal to minus sin y. These two relations you can have by considering the angle minus y as 360 minus y. So 360 minus y, cos of 360 minus y will be cos y, and sin of 360 minus y will be minus sin y. So use it here now. So this cos of minus y will become cos y. So you will have this here, cos x minus cos y whole square. And here sin of minus y will become minus sin y. So this minus will be removed from here, and the sign outside will be positive now. And now this is a minus b whole square, this is a plus b whole square. Just open the squares. You will get cos square x plus cos square y minus 2 cos x cos y plus sin square x plus sin square y plus 2 sin x sin y. So further it is equal to this cos square x plus sin square x will become 1. This cos square y plus sin square y will also become 1. So 1 plus 1 means 2. So it is 2, and from these two terms I am taking out minus 2 as common. So minus 2 is common. You will get cos x cos y minus sin x sin y. So this is your distance BD square. This is BD square. Now what is AC square? AC, distance square. And also you can put distance symbol for there. AC square now. Coordinates of A are 1, 0 and coordinates of C are cos x plus y sin x plus y. So the distance will be 1 minus cos x plus y square plus 0 minus sin x plus y square. Now open these squares also. You will get 1 plus cos square x plus y minus 2 cos x plus y. Here it is 0, so it will simply become plus sin square x plus y. This cos square x plus y and plus sin square x plus y will become equal to 1. 1 plus this one will become 2. So you will get 2 minus 2 cos x plus y. Now this is the distance. This is the square of the distance BD. This is square of the distance AC. But square of AC and square of BD are equal. So these two quantities must also be equal. So equating these two, what we are going to get? Equating these two, that means I am using now AC square is equal to BD square. So AC square is 2 minus 2 cos x plus y is equal to BD square. BD square is 2 minus 2 times cos x cos y minus sin x sin y. This 2 will be cancelled. Minus 2 times this is equal to minus 2 times this. Minus 2 will also be cancelled, and you will get cos x plus y is equal to cos x cos y minus sin x sin y. So this is fundamental identity of sum of the angles, cos of sum of the angles. Now a little bit change here will give you almost all the relative identities. So just replace y by minus y. So what you will get? Here you will get cos x, this plus y will become minus y is equal to, here you will get cos x and cos of minus y. You know that cos of minus y is also equal to cos y. So it is cos y minus, this is sin x, and here you replace y by minus y, you will get sin of minus y. But sin of minus y is minus sin y, so you will have sin change here and sin y here. So this is the second formula, that is cos x minus y is equal to cos x cos y plus sin x sin y. Now consider sin x plus y. Consider sin x plus y. We know that sin of x plus y is cos pi by 2 minus x plus y, because cos 90 minus theta is equal to sin theta, that we are using now. So it is further equal to cos pi by 2 minus x plus y. So now it is cos, this is your x plus y, cos x plus y, and for cos x plus y you are having this formula. So use it here, you will get cos pi by 2 minus x cos y minus sin pi by 2 minus x sin y. Here little bit change is there. It is actually minus y. So formula will be for cos x minus y, and you will have a positive sign here. Now, what is cos 90 minus theta? Cos 90 minus theta is sin theta, so it will become sin x. So it is sin x cos y plus sin 90 minus x is cos x, so it is cos x sin y. So this is the formula for sin x plus y, that is sin x cos y plus cos x sin y. Once again, if you replace y by minus y in this formula, you will get the next one, that is sin x minus y is sin x cos y minus cos x sin y. So these are the proofs of basic fundamental identities of trigonometric functions of sum of the angles. So we will proceed further in the next video. So I hope you are liking these videos. You will like, you will share, and you will subscribe the channel as well. So once again, because this all is possible because of you people, so once again I am thankful to you. Thanks once again, and we'll meet in the next video.